Yeah. Arno, is it okay?
Okay, you can start.
Okay. So hello everyone and welcome to ArianeGroup's first Ask Our Engineers live stream. Okay, so we're really excited about it. My name is Mathieu. I'm myself an ArianeGroup engineer working on Ariane 6, and I will be hosting this performance tonight with some of my dear colleagues. So we really hope that wherever you are safe. And we thought that due to this particular circumstances, maybe we could gather all of our forces and try to provide you with a short break talking about science and space. Because when we're not designing or manufacturing or developing or launching rockets, we actually love to talk about it. And that's what we do best, I think. So we asked our community to send us a lot of questions about what we do, and we'll try to answer most of them tonight. So with me, I have on the Ariane team my experts. And please do, as in school, you wave your hand when you hear your name. So first one will be Cécile. Are you there?
Yeah. Hi, yes.
Yeah, she's there.
Hello.
Rashida.
Hello, I'm here too.
Hello. Okay, Arnaud.
Hey, good evening.
Hello. Et enfin, last but not least, Laurent.
Hello, everyone.
Okay, so hi everyone. I can hear you. First question, very simple one. How do you feel, and are you ready to answer these questions?
Yeah.
Hey, yeah.
Yeah, fine. Yeah, very good. Ready.
You're fully pumped up. That's that's cool. Okay, so the first question we can take is from Lucy on Facebook, and she asked us very simple but important one: why build rockets? And I think Cécile, you could answer this one.
Yeah, for sure. Very, very important question, in fact. So a rocket, it's simply a transport vehicle from Earth to space, and so we use them to bring goods to space. These goods, we call them payloads, and these payloads are most of the times really heavy, several tons, very expensive and very fragile also, and we have to put them with a high reliability into space. Most of the times we send telecommunication satellites in order to have access to internet on Earth or to transmit television programs. Some other satellites may help for geolocation like Galileo or for Earth observation. In sometimes we have some very specific missions also, scientific missions. For example, the Rosetta mission, it's a space probe that met the Rosetta, the comet Chury, and the objective was to know the composition of the core of the comet. Another example, maybe we have sent some what we call ATV, automated transfer vehicle, and it was used to join the International Space Station and to bring water, food, and propellant and much things to the teams into the ISS. And maybe a last example is a space telescope also that was sent with Ariane 5, and Herschel Planck was the name, and it was used to see very far in the universe to better understand the origin of universe. So as we see, we have a lot of different things to bring into space.
Yeah, actually, last week there was also a space probe, so it's called Bepi Colombo, which was sent by Ariane 5 in 2018, and it did a flyby. So it just actually passed by Earth. I think 12,000 kilometers away from Earth, and on its way to Mercury. So yeah, so thank you, Cécile. We do a lot of different things with it. Okay. The second question we have is from Charles. It was on Twitter, and he asked us, and it becomes technical, you'll see. So how does Ariane communicate with the ground during its flight? Is there an antenna on each one of these stages? And what data does it send back to the ground stations? Okay, I'll take this one. Okay, so yes, actually, we're actually using antenna to communicate with the ground, and we communicate with ground stations. So a ground station, you can imagine, this really big antenna dishes. You can see sometimes in movies. That's exactly what we do. But the thing is, the rocket is moving so fast around Earth that we have to use a set of different ground stations. We actually use a network of stations because it's not like one station that can follow it here. And where do we put this antenna? We put it on the upper stage, really on the very top part of the launcher, because it's the part of the launcher that stays during the entire mission. That's also where you have the onboard computers. That's where you have the batteries and so on. So we need to keep it close to the brain of the launcher somehow. And finally, what type of data? Actually, we try to measure as many things as possible. We try to monitor that everything's going correctly, so that all the different major events like separation of the stages or separation of the spacecraft is going well. And also we look at all the propulsive parameters, the temperature, the pressure, and so on, because in case we have an anomaly or an issue, we have to be able to track back the anomaly and understand what happened. And this is how we keep our launchers very reliable. We can also assess this data and see if we have margins and get more performances. I don't know if you want to add on this topic.
No, you said everything.
That's what I wanted to.
You're perfect. Don't worry.
Okay. So we'll take the next question. So this one comes from Alice. It was on Twitter, and she asked, how long does that take from the first screw that you put on the launcher until launch? And we have also another question to the same type from William and Archer on Facebook. So how much time do you need to assemble the whole launcher, including the payload, including the satellite you put on top? So Rashida, maybe I think this one's for you.
Yeah, so I will start to answer the question about the final assembly. How long does it take to assemble the whole launcher? In fact, you have to know that the final assembly of the launcher is done in the buildings of the Space Center in Guyana. In fact, the operators and the engineers who are working in Kourou will receive the different parts, which are for building the launcher, the stages, and the fairing coming from Europe, and also the payloads, which are the satellites to be launched. Then the operators, after they receive all these parts, will assemble the stages and the satellites like a Lego game before the launcher is complete and ready to launch the satellites. So to answer the question, which was about the number of the time needed for that, it takes about 30 days for assembling Ariane 5 launcher with the payloads. And for Ariane 6 launcher, we try to divide this time by roughly 2. And the first question was about how long does it take from the screw?
Yeah.
First screw, yeah. So this one, I think it's tricky, because in fact we have to organize all the manufacturing process so that at the end all the parts come together so that we can assemble and do the launch. So that means that the different parts can be also built a lot of time before we are using them. So to give you, for instance, an order of magnitude, the integration of one of our stage in Bremen, in Germany, for assembling it, we need a couple of months to be ready and then to send it in Guyana. So it's a very long delay compared to the 30 days we need to assemble the complete launcher. So I hope
you said
it answers.
Oh yeah, okay, but and I think also that there are parts that take a long time, in particular on the engines. So sometimes you need to procure the parts.
Exactly. That's why it's it's not so obvious to estimate the long term. So we need a lot of time to procure the screws, and also time to integrate all the little small parts that constitute the stage.
Okay, thank you. So, okay, now we had technical questions, general questions, and now we fall into a new category, which is cute questions. And this one is like super cute. Okay, it's from another Lucy, and she asks us, could we use little hamsters running on wheels to power the rocket? And she also sent a very, very nice drawing, and thank you for that. It's quite inspiring. And I think this one is for you, Arnaud, because kids love you because they think you are harmless.
Oh, thank you, thank you. So I will answer that question. Actually, I've read the question on our social media, so I've made the calculation, so I'm really prepared for that. And the answer is no.
Oh,
Sorry, no. You should use squirrels actually. No, it's a joke. Okay. Let's try to compute together. We have one hamster.
Arnaud, you actually run the math of this.
Run the math.
Yeah, you actually did the computations.
More or less. Let me follow. You will see.
Okay.
One hamster. It's approximately 150 grams. Let's say our hamster will run 8 hours per day, which is quite simple actually. At 1 kilometer per hour, it's slow for hamster. You have to know. The wheel actually it's 20 centimeter diameter. So at the end we have 0.4 watts of work done by this hamster. You have to know that our main engine, the Vulcan, it's 15 megawatts. So we need 40 millions of hamsters to do that. and if I may, to figure out how many 40 millions of hamsters represent, I made another calculation. You can.
You're obsessed with these things.
You will see. One second. Everybody can figure out how long that it takes. 1 second. 1 million seconds. It's approximately 10, 11 and a half days. 40 million seconds. It's 1.3 years. But remember, our hamster will work only 8 hours per day. So we have actually 1 hamster per second during 4 years, which is actually the year our little and cutest girl asks the question. 4 years of life, and with 1 hamster per second during your 4-year-old life. That's pretty big, actually, pretty lot. And you can finally, and that's my final recommendation for you, please ask your parents first.
Okay, so the bottom line, Arnaud, there is, do you think ArianeGroup should patent this technology before Lucy does?
Maybe as I said, squirrels are better. So
okay, we'll patent it with squirrels.
Yeah, but with an improvement or something like. But we are working on it.
Yeah. Okay. So it really gives you an overview of the type of questions we allow in this in this group. So you can push more of them. Actually, the next one is kind of the same type. I love this one. So it's a fun one from Florine. It was asked on Facebook, and she asked, "Is building a rocket like building IKEA furniture?" Okay, and at the end of the day, do you guys and girls end up with an extra screw that is useless? We all know the situation. So Rashida, can you tell us more about this one?
Oh, okay. So is it furniture for the hamsters, or what is it exactly?
No, the sort of one you find at IKEA. Yeah.
Okay.
We have to say that no hamster have been harmed during the calculation.
Okay.
That's important.
That's the most important. And how many can you fit in the rocket? How many hamsters?
Come on,
Can we fit them in? Okay, so forget about
bit tired. Okay. I will do that.
So coming back to my IKEA furniture, As for assembling, in fact, your IKEA furniture, we need procedures and tools to build the rocket. But with no offense, the comparison stops here because we are a bit more sophisticated than that. Okay. Indeed, in the way we work, to avoid any mistakes, we rely on our control and quality system. So, which means that at each steps of manufacturing and assembling, the set of operations are controlled and validated. So, if something is going wrong, like a piece is missing or is not conform, we will raise what we call, make it technical, a non-conformance report. And in fact, this is just a way to say, stop, there is something which is not okay there. So, for instance, if a screw is missing or it's a different one, we say, okay, we stop here, which you don't do when you have your IKEA furniture. Much of the time, you are just trying to build and to go through it and saying, yeah, I can manage. Okay, so thanks to our sophisticated process, we treat the problem quick, let's say it like this, so that it doesn't happen again. So therefore, to answer the question of Florin, it was Florin?
Florin,
yeah. There is no chance that at the end we have useless screws that are left, and also no chance that we launch the rocket with a missing part, which is, of course, the most important, because if something is missing there, it's a bit tricky.
Yes. And so, Rashida, I think you're the only one that actually does not follow the IKEA manual and enforces everything. Yeah. I mean, if a screw is missing, I stop. I will sleep on the floor, but I will go through this entire manual. And I think the big difference with our process too is that we put text in our manuals, which is
that's true. Yeah.
Okay, thank you very much. Okay, next question. It might seem simple, but it's not exactly. So Chris on Facebook asked us, why don't we launch from mainland France? I mean, why don't we have a launch pad next to the Eiffel Tower? That'd be so cool. I think Laurent, you can answer this one.
Yeah, as we were discussing earlier, we're launching our rockets from French Guiana. So for those of you who are not completely familiar with the French geography, French Guiana is in South America, just very close to the equator. Actually, we do that for several reasons. One of them is for safety reason. If you have an anomaly or so on, you'd like to have a lot of space around you. So, of course, just nearby a very big city like Paris or inside a big city, that's not the best idea. But also, we do this for very ground basic reason, for performance, because we're engineers, so we love performance. And actually,
I think, Laurent, you have to explain what performance is for us.
Here, basically, it's more weight, mass, because we like to put the biggest satellite possible in orbit. So, in fact, we would like to rely on two things, which are a bit technical, but I'm pretty sure everyone will understand. The one is that the Earth rotates. Yeah, that's very technical. And actually, the second one is that the Earth is a globe. Second one, which is complicated. Actually, when the Earth rotates, it's like a carousel on a playground for children. When the carousel turns, if you're on the side of the carousel, if you're not holding, if you're releasing your grip, you will fall outside of the carousel. It's called the slingshot effect. In fact, when something is turning, if you release it, it will be sent away. That's one of the effects we want to use here. Our slingshot, our carousel, will be the Earth. So the Earth is rotating and doing the job for us. It's rotating every time. So we want to launch using this force. So for that, as the Earth only spins in one direction, we will mainly launch facing eastwards and sometimes facing north, but for other reasons. So we need a land with a lot of space and with a clear range facing east. And also the second reason is still that linked to the fact that the Earth is spinning is that it's a globe. So if you take a globe, if you cut a slice close to the pole, it will be a very small slice. But if you cut a slice very close to the equator, it will be a bigger slice. C'est toi qui recommence du coup, Mathieu, pour reprendre la main.
Olivier va me donner le go. Je te laisse me donner le go à l'oral sans problème, Olivier. Ok.
Ouais, ok.
En même temps,
Attends.
It can go.
Attends.
Go.
Ouais, c'est bon.
C'est bon? Okay. So sorry, we have a series of technical issues that are independent of our will. But Laurent, it doesn't mean that your answer was not interesting. So,
Okay, no problem.
you can resume with it, please.
Yeah, so I was saying that we're launching from French Guiana for two main reasons. One is that the Earth rotates, so we like to launch facing east. That's the second one, is that the Earth being a globe, you have a bigger slice of carousel if you're close to the equator, so bigger, more energy from the slingshot effect if you're close to the equator. So we're looking for French territory with a clear view to the east, and if possible to the north for some launches, and close to the equator, and French Guiana is pretty perfect for that. And also, it's an area where you have no earthquakes, so there's no risk for installations, and also, even if there's storms and regular humid period, there are no hurricanes there, so you can launch all year long with no problem. So that's very interesting to go there.
Yeah, so I was very interested, Laurent, by your answer and your metaphor. And my question would be like, have you ever experienced like falling from a carousel? Because it's quite bad.
It's a child. No, I haven't been abused when I was a child. Playgrounds, no problem. Don't worry.
Okay. Okay, we wanted to be sure of that. Okay. Next question is from Robert on Facebook, or Robert, I don't know. And his question is, what are the differences between the different engines that you have on the stages of a rocket? Okay, we know that our rockets are made of different parts. So what are actually the peculiarities between these different engines? So Arnaud, maybe you could take this one.
Yeah. Okay, I see your point. I think the question is about why we have sometimes solid propulsion, sometimes liquid propulsion. Okay. Basically, solid propulsion is very powerful, a little bit dangerous to industrialize, to integrate, and to manipulate, but very powerful. So that's the perfect way to escape from the main force which retains us on Earth, meaning gravity. So usually, and Ariane 5 is typically designed with that. We start with solid boosters to escape from gravity. Then we need quite a long and enough powerful power, and liquid propulsion is perfect for that. On Ariane, we use liquid hydrogen and liquid oxygen, both mixed together for our main propellant, as we say in space industry, and it's very interesting for reaching the desired orbit. For launchers is mainly the two, both liquid or solid the type of propulsion. But I can add that we have also electrical propulsion when on satellites, for instance, or probes, to express a very long but very low powerful power to propulsion system to reach longest distance, as we said, for a probe to explore another planet, for example.
Yeah, I think what is important to have in mind, and I don't know if everyone realizes it, but when we say liquid propulsion, and you say that it's hydrogen and oxygen that are liquid.
Yeah.
I mean, most of the people know that oxygen is actually a gas. If it's liquid, if it's cool enough, if we manage to cool it enough. So what we have to do is to cool it a lot. So that's why we're talking actually about cryogenic propulsion. And then the other big advantage is that with solid propulsion is like you ignite it and it will never stop. And with liquid propulsion, you can do different things. So with our first stage, Yeah, with the Vinci engine actually developed by ArianeGroup that we will use on Ariane 6, we'll be able to reignite it. So we will do a very, very funny orbital maneuvers, as we call it. So we can address different orbits in different missions. Yeah. Okay, next question is very generic, but it's an important one too about ArianeGroup. It comes from someone called Mathieu, which is a great name. It was on Twitter. And he said, what type of career and studies did we do before getting this job at ArianeGroup? So maybe, Cécile, you can give us some insights about it?
Yeah, I think everyone can answer on his own experience. So most of the time in ArianeGroup in France, to be engineer, we have an engineering degree. So we have spent the studies in engineering school. So it's 5 years after the French baccalaureate. I guess, by the way, in Germany, there are more in university to have their in the engineering degrees. Most of people in ArianeGroup come from very specialist schools in space or aviation, for example. But from my part, I come from a generalist school. And by the way, I have begun not in the space industry, but in the nuclear industry. So, by the way, we can do also with every, even if with a generalist diploma. And yes, I wanted just to maybe to add something. You don't need to be an engineer to work in ArianeGroup, by the way. You can also, with a technician degree, or we have also operators that are really putting screws on the rocket, and so no obligation to have an engineering degree.
Yeah.
I don't know about you guys and girls.
Engineering degree here. I don't know if you have other backgrounds, but
maybe you are fond of
Same
space
here.
and you have just begun to work in space directly.
I knew I wanted to do that. It happens like most people.
I've started to work on televisions in Philips in Netherlands. So by the way, hello Netherlands, if you are listening to us. Yeah.
Wow. Okay.
So that means that you can work in another company before, and then you can also join ArianeGroup after a while. That's very good.
I think we can also add that we have many different types of jobs, like in any companies. I mean, we have legal services, contracts, we have information technology people, communication. So, I mean, if you want to live the dream, any of those jobs are available at ArianeGroup. So.
Even one of our colleagues in Lemuro was producing ice creams before coming to produce launchers. So you see, nearly every background can open you a job in space industry.
Yeah, because we're doing cryogenic.
And now you see my point.
That's why we hired him. Okay. Next question is very technical. This one, and it would be for you. This one, Laurent. It's Stéphane, which asks a tricky question, which is: will the Ariane 6 chronology be similar to the one of Ariane 5? But I think the first question is, what is a chronology?
Yeah, so actually the chronology, in fact, everyone knows it. Everyone knows like the last 10 seconds of the chronology, which is the final countdown we see at every launch, every country with the 10 seconds that are counted by the director of operations. This is just the end of the chronology. In fact, the chronology, it's all the operations that lead to this final countdown and the liftoff. And in fact, you start like even the night before launch, so even almost a full day before you want to launch. The first operation are started there, and then you work like the really dense part of the chronology will be in the last 5 hours before the launch. Actually, what we were talking earlier about propulsion system, it's the main factor that will create the structure, the architecture of your chronology. So Ariane 5 and Ariane 6 have the same propulsion architecture with liquid center stage, and 2 solid rocket boosters. So their chronology is pretty close, but details are very different because technologies are different. The engine have evolved, the tank structure is not the same, and so on. Actually, during a chronology, the main activities you have is filling your tanks with liquid oxygen and liquid hydrogen. It's not exactly as filling your going to a regular gas station and filling your car. It's a bit longer because, as we're saying, it's very cold. We're talking like minus 200 degrees Celsius. So it's really very, very cold. So you have to do what we call a chill down process, just going step by step to go to lower temperatures, fill your tanks. Then you will start all the electronics, where Mathieu was talking about them earlier, about telemetry and so on. All the computers on board the launcher have to boot. Like your own computer, it takes a while to start, and it's the same for our launcher. We also have to prepare the launch range, like the people in French Guiana who will be working with us on the ground to help us do the launch, like the radar tracking stations, the telemetry stations, and so on. And once everyone is ready, synchronized, we'll enter like the last 10 to 12 seconds, what we call the synchronized sequence. And this is really the last minute, last 10 to 12 minutes, of course, which is the last part where the launcher is fully ready, the ground system is fully ready, and we're just waiting to make sure that the weather is fine, that there's no one in the vicinity that may be harmed, no airplane, no boat, and so on. And then we just finish the process and go to the final countdown and lift off and soar to the sky.
Magic.
Thank you. Wow. We have another question about our jobs. It's a live question received from Bastien. He simply wants to know in which field exactly we're working right now in ArianeGroup. So, Cécile, if you want to start and quickly.
Okay, I have started with very technical topics, but now I'm what we call on a program support. So I help program managers to deal with the planning, the costs, and the technical progress, and so on. So.
Okay, Rashida.
I have also started on a technical background. I worked at the beginning in the company on the automated transfer vehicle, doing thermal engineering. So then after I had the chance to do different kind of jobs on different projects. So it was very nice and very enriching. And now I am doing same job as Cécile, helping programs on planning and cost for Ariane 5.
Okay, Laurent?
I'm working on the Ariane 6 industrialization team. It's the people who are working to see how we will build the rocket and how we will control it to make sure all the pieces fit together and we have no problem, like we were saying, like Rashida was presenting earlier.
And finally, Arnaud?
Squirrels, mainly. No. I've started my career in ArianeGroup as a mission analysis engineer. Mission analysis is to prepare the flight plan of the launcher for a dedicated mission. And now I do project management for some parts of the new Ariane 6 launcher.
Okay, thank you. Yeah, I won't describe my.
And what about you, Mathieu? Come on, you, Mathieu.
Every 2 years, they get me doing something different. But now my main job is we have very interesting customers with very, very nice ideas we didn't think about before. So we try to adapt Ariane 6 to it, even though it's not flying yet. So yeah, this is the sort of weird stuff we do, but I love it. Okay, we are almost at the end of the show, and I'll take a last question, which is from maybe the same Robert from Facebook. This one is nice. Which series or movies showcase the best and most realistic space battles? I think this is really the thing I can say about that is that if you really think about the way spacecraft move in space, and if you compare it to what you see in movies in general, what they have the spacecraft doing in movies is really similar to air fighters. So it's really inspired by this air battle. So, but actually, if you have a spacecraft this way and you want to steer it, what is cool with air battles is that you have air, so you can use drag, lift, and so on to do this the steering. Okay, if you want to do the same in space, then you need to have a thrusters there to do that, the thrusters there to move, and then to stop the motion, you also need to have thrusters because you cannot really actually stop this motion in space. So this is really a big issue. So it means that you need to have thrusters everywhere. I found this picture today, for really nice. This is a space shuttle.
Yeah.
Many thrusters on the nozzle. So that's what we need to do. So imagine if you want to do this battle, that's what you have to do. And remember that you won't hear the pew 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 of the lasers in space because there's no air again. So so Star Wars is really nice for that, but I'm not sure it's really realistic. But maybe there are examples.
It's not good. A movie without sound, it's not a space movie.
It's a Kubrick movie. In that case, I guess. Okay, so do you have any other examples of series you like about space that would feature very good space battles?
Yeah, space battles. Space battle is difficult, but Gravity, even if you will find tons of the website and video that explain that there are some mistake. Okay, but the silence in Gravity, the way they move, I think that's pretty great. And you talked about the Kubrick movie, 2001 Space Odyssey. It was with the sound of Space Odyssey was an amazing movie for that.
Wall-E is the best.
Okay.
Unknown.
No, actually, the space battle I really like is the one that is in First Man, where you have Neil Armstrong with the Gemini spacecraft trying to catch into a stage. And actually, it's really a struggle because it's trying to control its own spacecraft. They have an issue. See, if you haven't seen this movie, I mean, this part is really the one I preferred because it really shows you how tricky it is to have a spacecraft moving in space. And when it goes wrong, it goes really, really bad. So that's it. Okay, I think it's time to end up this show. So I'd like really to thank everyone that sent us questions, that actually watched the show, that sent comments. We can see you. We saw your comments. Thanks a lot for that. I really hope you had a nice time with us. I also would like to thank all of our experts. Thank you for doing that. I'd like to thank also the technical teams that allowed us to set up this show. Mélisandre, Alizé, Arnaud, and Olivier. I hope I'm not forgetting anyone. If we didn't answer your questions, do not worry. We will actually try to answer them either directly or through posts on the social network. Okay, you can really follow ArianeGroup on Instagram, Facebook, and Twitter. So we're really active on this. So do not hesitate to send more questions. So again, thank you. Have a very good evening. I think, at least in France, it's about time for you to prepare to clap and cheer all the medical staff that's doing a great job right now. So we prepare that and we leave you time for that. So please stay safe, stay curious, and hope to see you very soon. Bye-bye.
Bye.
Thank you very much.
Bye. Thank you. Thank you. Bye.